Welcome to Saraswati School of Science Practical Sessions. Today we are going to discuss the very first practical of Standard 12 Science. The very first practical is to determine the resistance per centimeter of a given wire by plotting a graph for potential difference versus current. Now coming to the aim of this practical, to determine the resistance per centimeter of a given wire by plotting a graph for potential difference versus current. Now question arises, what exactly resistance means? Resistance is nothing but the measure of opposition of current flow in a circuit. Yes, now moving to the apparatus material required for this experiment. The very first thing we need is a wire of unknown resistor whose resistance is need to be determined. Second, we need to have battery, voltmeter, milliammeter, rheostat. Now here question arises, what is rheostat? Rheostat is nothing but what? A variable resistance which is used to control the flow of current in the circuit. Next is plug key. What is plug key? Plug key is nothing but the switch in order to connect or disconnect the circuit. Next we need connecting probes, that is wires, and a piece of sandpaper. Here question arises, why we need piece of sandpaper, sir? Piece of sandpaper is needed in order to remove the insulation on the ends of the wire. Clear? Now moving to circuit diagram. You can see the circuit diagram where you have a ammeter, we do have voltmeter, we do have unknown resistance, we do have a battery, key and rheostat. Clear? See, ammeter are always connected in series, as in series connection current flows throughout same. And voltmeter is connected into parallel because we know that in parallel connection voltage remains constant. Till this clear? Fine. Now moving to the theory of this experiment. According to Ohm's law, the electric current flowing through a conductor is directly proportional to the potential difference across its ends, provided the conditions are there, that is physical state conditions, where pressure, temperature and dimensions of the conductor remains unchanged. This is the fixed physical conditions of Ohm's law. If I is the current flowing through the conductor and V is potential difference across its end, then V is proportional to I. Now, in order to remove this proportionality, we need to have proportionality constant, and that proportionality constant is R. And hence we can have V is equal to Ri, where R is a constant of proportionality and it is termed as the electrical resistance of the conductor. Resistance R depends on the dimensions and material of the conductor. Remember, very important, resistance value depends upon dimensions and material of the conductor. The relationship between the resistance of a material and its length and area of cross section is given by formula that everybody knows. R is equal to rho L by A, where rho is specific resistance or resistivity and is a characteristics of material of the wire. Till this clear? Very good. Moving to the procedure of this experiment. Now for the procedure, very first is, that is very important, that I have given, already discussed about the use of piece of sandpaper. Clean the ends of the connecting wire with the help of sandpaper to remove any insulating coating on them. Very important point number 1. Second, connect the resistance, rheostat, battery, key, voltmeter and ammeter as shown in figure. Third point, make sure the pointers in the voltmeter and milliammeter coincide with the 0 mark on the measuring scale. That is very important. If they are not at the 0 mark, then you will be able to have some error into that instrument and you need to eradicate that. If not, adjust the pointer to coincide with the 0 mark by adjusting the screw provided at the base using a screwdriver. You will be able to see there is a screw given on the base. You need to what? You need to adjust the pointer to coincide with the 0 mark by using screwdriver by adjusting that screw that is provided at the base. Next, fourth point is note the range and least count of the given voltmeter and milliammeter. You need to check the range of voltmeter and milliammeter and you need to calculate the least count for the same. Fifth point, insert the K and slide the rheostat to end where the current flow is minimum. 6. Note the voltmeter and the milliammeter reading. You need to note down the reading of voltmeter as well as corresponding reading of milliammeter. 7th, remove the key and allow the wire to cool. After taking one reading or two reading, you need to give time to cool the wire. Again insert the key and slightly increase the voltage by moving the rheostat. Note down the milliammeter and voltmeter reading again. 8th point, repeat step 7 4 times by adjusting the rheostat, taking different values of voltage, and you need to get the corresponding values of current. Document the readings in a tabular column, that you need to put it into observation table. Now you can see over here, as per the circuit diagram, we have made the connections for the following instruments, and we can see that this is the battery eliminator or the source, this is your milliammeter, that is your ammeter, this is your voltmeter, this is your key, This is your unknown resistance and this is your rheostat. Here rheostat is used in order to vary the resistance and we can get the voltage, and for similarly corresponding readings of current can be noted down. Now here you will be able to see one thing over here, that is by moving this I can vary the voltage. Similarly I am going to get the reading in milliammeter here. You have to note down the reading of voltage as well as the current, and by taking the ratio of V by I we will able to get the value of unknown resistance R. Now moving to that, first I need to calculate what the range of milliammeter. The range of milliammeter you will able to see, that is from 0 to 500. 0 to 500 is the range of milliammeter, and the least count of this ammeter would be, you will be able to see that it is from 0 to 100 there are total 10 divisions. So 100 by 10 is nothing but 10 milliampere is the least count of this milliammeter. Is this clear? Very good. Now about voltmeter. Voltmeter you can say the range is from 0 to 2. It is from 0 to 2, and one thing you will be able to notice that least count for this voltmeter, that is from 0 to 0.5, we are having 10 divisions. So your answer is 0.5 divided by 10, that is 0.05 volts. Till this clear? Okay. Now there is meter scale. Sir, why meter scale is used over here? The meter scale is used in order to determine the length of this wire used. This length of the wire used is need to be determined by using, very good. The least count of this meter scale is 0.1 centimeter, and that is 0.1 divided by 100, that is 0.001 meters. Clear? Okay. Now what you will do? You will just simply, by varying the resistance, you will vary the voltage and correspondingly you will note down the readings. Till this clear? This is the simple basic performance or demonstration of the experiment. Now we are going to record observations. For that, the first is range of emitter. The range of emitter, the scale was calibrated from 0 milliampere to 500 milliampere. Then least count of emitter, we have seen that there are, for 10 milliampere is considered to be the least count of the emitter that I have already shown you before. Range of voltmeter is from 0 to 2 volts, and least count of voltmeter is 0.05 volts. Least count of the meter scale, that is 0.001 meter, or you can say 0.1 centimeter, that is the minimum measurement that can be made by the instrument, is considered to be least count of that instrument. Now length of the given wire is 1 meter. The unknown wire is being measured with the help of thread, and with using the meter scale I found that it was 1 meter, that is 100 centimeter. Till this clear? Now what I did, by varying the resistance of the rheostat, I got the reading of voltage, that is 0.25, and similarly I recorded the corresponding reading of current in milliammeter, and I got 60 milliampere. Clear? Second, 0.50 I got 110, 0.75 170, 1 210, 1.25 290, 150 820. Here you will be able to see that as soon as you are increasing the voltage, simultaneously the current readings are increasing, so V is proportional to I. That means Ohm's law is obeyed over here. I have converted this milliampere into ampere by dividing by 1000. So 60 divided by 1000 is 0.06. Similarly, I got the values of ampere over here. Now R is nothing but what? V by I according to Ohm's law. So we do have value of V, we do have value of I. Dividing value of V by I, you are going to get the answer of R. So first is 0.25 divided by 0.06. I am going to get my answer is 4.16 ohm. Similarly, I calculated various readings. I calculated the value of resistance, and finally I did the mean of it. Finally, I did the mean. Mean is nothing but average of all the observations, and it found out to be 4.47 ohms. Clear? Now you need to plot a graph on a graph paper, taking V as your x-axis, voltage reading as your x-axis, and ampere readings on y-axis, and you will be able to plot all the points, and you will see that it is going to come a straight line like this. Now in order to determine the slope of this graph, you need to do nothing but what slope, that is opposite side upon adjacent. Opposite AB, adjacent is BC. So AB by BC, I am going to get one point, that is, I have taken one reading, that is 120 into 10 power minus 3 divided by 0.55, corresponding reading of what? Voltage. So I got my slope, that is 0.218. Till this clear? Okay, so here you can see that this AB is nothing but giving you corresponding current reading, and this BC is giving you corresponding voltage reading. So slope is nothing but AB by BC. So this is I and this is your V. So it's I by V, that is nothing but reciprocal of resistance. So slope is nothing but what? Reciprocal of resistance, means you are getting conductance, and in order to determine the resistance, you need to take reciprocal of conductance. Till this clear? So to get the final answer of resistance, you need to do 1 upon 0.218, because it is I by V. We need V by I. For getting V by I, what I need to do, that is 1 upon 0.218, that is I need to reciprocal this slope in order to get the answer of resistance. Till this clear? Fine. Determine the slope of the graph. The resistance of the given wire is then equal to reciprocal of the slope. Therefore, R is equal to 1 by slope, that is equal to BC by AB. I have reciprocal of what? AB by BC, that is BC by AB, and I am going to get my answer. R is equal to 1 upon 0.218, that is 4.59 ohms. So from the graph, R is equal to PC by AB, that is 4.59 ohms, that is my answer. Now resistance per unit length of the wire. Resistance is 4.59 and length of the wire is 1 meter. So resistance per unit length is same, that is 4.59 ohm meter. Here remember that the length of the wire is 1 meter, that is why the value is not changing. If the length is changing, then you will be able to see that there will be variation in the answer over here. Clear? So 4.59 by 1, your answer is 4.59 ohms per meter. Now finding out the error in this resistance. So error in the resistance, we can V is equal to IR, we know the equation. From that we can formulate the fraction error equation, that is delta R by R, that is equal to delta V by V plus delta I by I. From that I can calculate delta R, that is equal to R into delta V by V plus delta I into delta I by I. So here one question arises, what is delta V and delta I, sir? Delta V and delta I is nothing but least counts of voltmeter and millimeter. So least count of voltmeter was 0.05 and least count of millimeter was 10. So I am putting the values and I am taking any one point on the graph, that is from 0.875 voltage reading, corresponding reading of current is 193.33, and if I am going to manipulate this, I am going to get my answer 0.49 ohms. So this is my error. So any quantity can be represented what its absolute magnitude and its error. So my answer is 4.59 plus or minus 0.49 ohm per meter. This is my final result of what? The experiment. One more thing I can conclude from this experiment, that is the potential difference across the wire varies linearly with the current. As soon as you are increasing the magnitude of the voltage, you will be able to notice that there is increase in current correspondingly. Thank you.